Merci. So, good morning, everyone. Today is the 5th lecture. We're going into classes and a short introduction into Git, which you can use for your project, which starts next week. But first of all, we start with classes. And classes in Python, this is so-called object-oriented programming. So in Python, nearly everything is an object. And objects have types. So like lists, for example, lists are objects with type of list. And they have an internal representation. So you have, for example, if we have a list, so it's called list, which we declare in this way. Our internal representation are these two integers, for example, and you can use some methods to interact with the object. So on the other hand side, if you have your list, you can use, for example, some functions or methods called methods if you use them for classes or inside classes. So we can append 3, for example. So this is how you can interact and manipulate classes which are objects. And objects are instances of types. So your 12, for example, is an instance of an integer, and high is an instance of string. So your instance is your real data type, and your object is what you define first. So the advantages of this way of programming, object-oriented programming, is that you can use a divide and conquer development. This means you have much more structure inside your code, and you implement your classes. You have they're strictly separated so that you can test and use them in separated spaces. So just reduce complexity pretty much. And you can reuse classes. So like for modules, you can define your classes inside your Python files, and you can reuse them as often as you want. So, and for classes, you have separate namespaces, which means that if you have a class where you defined an attribute, it's x, for example, and you have another class where you named the same variable x, you don't have conflicts. So this is a separated namespace. This means that inside your class, you have your x, and in the other class, this is the other one, for example. What you can also do for classes, which we see later on in this lecture, is you can inherit from superclasses. So your class can be a general class, for example, and other classes, which are subclasses, can inherit from these classes and become the properties and behavior from the other class, but you can make them more specific if you want. But later in this lecture, we will see this as well. So to create your own class, you can see like for lists, these are already implemented in Python. But to make your project much more specific for you, you can define your own classes. And you can define your class. It has a name, has some attributes and methods, which are functions inside your class. So if you want to use your class afterwards, after you defined it, you have to make sure that you create an instance of it, like in this example, which is the same as here. You create an instance of your class to use your class for this point. But we'll see this as well right now. So at this point, we have our first class. It's called rectangle. So the class keyword is called class. So Python knows now you want to create a class. And then after that, you call them your name at this point. And our name is rectangle. And as every class is an object, every class can inherit from object. So to have the properties of the object. And after this, you have to define an init function, which means that every time your class is called, this init function is called immediately. So if we want to define our init function for our rectangle, we need ourself and an x and an epsilon. at this point. And after this, the self keyword means that stands for your class on its own. This means this is what happens inside your class. So self is your class at this point, the instance of your class. So if we have our x and our y, we have to assign them to our class. So after that, we can use them in other methods like area, for example. So if we want to know which area our rectangle has, we need to return self.x times self.y at this point. So this is our first class. This is a rectangle where you can assign x and y, and you can want to check the area of this rectangle. So at this point, you use the init function, which means that, for example, if we make a new instance, so our instance is called R at this point. And to create an instance of our class, we have to call the name, so rectangle at this point, and use our data attributes from the init function, like here, so x and y. So this example, we had 4 and 5, and this operation calls init immediately after the class is created. So this is the initialization method. So if we then want to check what our area is, let's put it out so we can see what it is. Use at this point, if we call it area, we use self.x and self.y, which are 4 and 5. So we become hopefully 20 at this point. So after this is called, our init function is called, and the 4 from here and 5 at this point is assigned to self.x and self.y. So our self.x and self.y are even 4 and 5 at this point. Okay. And if we, if we print our area, we become 20, so 4 times 5. Okay. This is the first insight into classes. At the other side, we can have, what I showed again. So you can access your data at every point. So if you really want to access your data that's called x or y, you can do this with the dot notation. So if you really want to know what's your x, you can print app.x, and you will become your 4. But this is not very common. So on the next slide, we will see what is more common to use. But if you really want to do this, you can access this way. Yeah, but let me see. Okay, what self is nearly passes as a convention. You'd like to see on the right side. You always pass self as an argument. This is from Python internally. It's common to use, for example. Okay, what do we have again? So we have the methods inside our rectangle. The area is method, so simply functions, but they're called methods inside classes. And Python always, as I said before, passes the self argument at first. So if we create a new the method after this, so how did we call it? On the next slide, it's a little bit more complicated. Next one. So let's compare two rectangles. Rectangle areas. Self is from PyCharm nearly passed, so it's automatically. But we want to have another rectangle, which you can do as well. So let's look. I mean, it's a little bit more bigger. No. So. Okay. So we have our class self here, which is what we have inside our class, and other. Other can be anything else, but at our point we want to have other as another rectangle, so we can compare them. So at first we want to have the area of our self, which is self.area. So with our self, we call this method at this point, and with the area other, we call the area method of the other rectangle at this point. So become this one. So then we want to compare. So if area self is greater than area other, we want to print out and say area self is bigger. Need to mix it in as a string. And else if area other is bigger, it's greater than area self, we want to print out area other is bigger. And if both is false, then we have both are equal. Okay, so what we do here is we have a new function and where we have our own rectangle, and we want to become another rectangle as an argument, and we call our area function for our own class and the area function for the other class. And then we want to compare which of them are bigger. So if we have another instance, it's called which is also a rectangle, and we have 6, 7. So we now have two instances of our one class at this point. And if we want to compare them, we then have our air dot with the dot notation and compare rectangles, and we need to pass the s as an argument at this point. And if we then want to compare them both, we have area other is bigger. What's here? Area other is bigger because the s has 6 and 7, which is bigger than 4 and 5, so 20 and 6 and 7, yeah, 42. Okay, so you can use methods, you can declare methods inside your classes, and you can also use methods with your own class, so as an argument as well. Okay, do you have any questions about this? This may be a little bit fast, I think, but if you have questions, feel free to ask. And then let's look about what I told you before. Let's make this a little bit smaller. Oh, sorry. So you can access your data with this dot notation if you really want to, but this is not common. So it's common to use getter and setter methods, because if you write your code, you may not want to access other ones, some attributes. So you can declare setter and getter methods for others to use them, so that they can change your data inside classes which you really want to. That this can be done. So we can declare getter and setter at this point. So this is only to set your variables and to get variables out of the class. So this is called setX, for example, where you have a new x and yourself x simply as the new x. One moment. And to get x, what you only do to return your x to the outside. So we can do the same for y at this point. Self.x y. Okay, so this is more common to use the methods to become these ones. So this is nearly not common to use. So instead you use r.getX, for example, to become the same value, but you know that this is you can use this attribute. Okay, what are methods used for? I don't get it at this point. Other than functions, which you simply declare in modules, you can declare methods which are for your class. So you can use with your class. So if you create this class, you can use the methods to change attributes of your class, or to use your class to compare, for example. You can do this as well with other functions, where you define a function. Let's say we can nearly make the same function like here, only with one and another. So this really makes the same thing like this one, but we have to make these both of them inside this function. But we can have to use this one. So this is the same. This is a function which compares two rectangle areas, one and another. And there's our R and our S, which is one and another at this point. So if we run this code, we should become 2 times the same output. So one for this, which we use with our class, and one for the other. But sometimes we want to change. Should I go from that? Oh, yeah. Sometimes we want to change some attributes from our class and want to use the attributes inside our class. So with this function, we have the methods inside our class. So we know what we use, what we have for functions, and what we can use. So at other points we can change. So if we want to set something else, we can change the attributes, which we cannot do as simple for inside functions. So to work with our classes at this point. So therefore methods are pretty useful. And to have your functions for your class stored inside your class, so you know where your functions are, for example. So you can import your class in another files, another Python files, and use the functions of your class. But instead, you have to also import your function, your class, and to import the function at this point, where you not always know where this is. Can you please show the code from line 20 and before this one? Is self always written in the function of class? So you mean in the init function? Yes, this is as a convention. So the first argument is will be passed if you have an instance. This means we need to declare the self at this point, which is done from PyCharm automatically, which is pretty useful. But if we use this as an instance, we don't have to declare the self. So this is the wrong function. We don't have to declare the self at this point. So the function knows that self is passed, the first argument. So here we have self and other for the function compare rectangles area. And here we don't need this because we have our R at this point and don't need the self to write it down there. But instead, a self is written at first of the function. Right. Okay. So first, did I set everything? What you can do as well is you can define attributes, data attributes before. So you don't only need to define them in your init function, but you can also do this before. Sometimes it can be useful. So if you want to set something before, which is always set at one value. So if we have, let's say, example value true. This is also possible to do. And what you can do if you don't want other, if this is a value you only use inside your class, this can happen more often than you think, and you don't want other ones to use them, you can protect or you can make them private. So if you want to protect them, you just simply write one of them, of these, how are they called? Underscore, of these underscores in front. So you can access them from outside as a user of the class, but with this underscore in front of the value, you know that you better do not do this. In other classes, in other programming languages, you can define them as protected or as private, so that other ones cannot even use them. But in Python, this is not the case. In Python, you're free to use them as well, but this is a sign to not use them at this point. Okay, is this clear? You think this is clear? Because if yes, we go to inheritance, and inheritance is what I said before, that classes can inherit the properties of more general classes, and this brings a lot more structure in your code and saves a lot of time, because you don't have to declare functions and methods more often. So with this diagram, and this is an example where you can have your most general class, which is animal, and as every person, every dog, and every cat is an animal, not every animal is a person, a dog, or a cat. So, or like every student is a person, not every person is a student, and students have other properties than persons. So for example, a matriculation number, which not every person has a matriculation number, but every student. But every student has also the properties of every person. So if we want to make this a little bit more visible, we start with person. We can create the class animal as well. So let's start with the class animal, which inherits from object, because everything is an object. And we have simply an init function. Sorry. We have an init function where we have an age, for example. So every animal has an age at this point. So self.age is our age. And after this, we don't have pretty much for common. We have this setter and getter method. So we have define set age age, and we have our getter method. Make this a little bit more clear. So, and where we return our age and self.age. So if we have an init function at this point and we do not use our self, for example, for the rectangle, I forgot to say about this. If we don't declare them to the self point, we do not know that this belongs to the class afterwards. This means if we don't assign them to self.x and self.y, we cannot even use the other functions. This means if we want now to run our code, we become a exception, because we don't know what is x, because x is not even set. So we need to have the self.x. So the self x is set for the class, so that we can use these attributes. Okay. So here we have a simple implementation of our animal, which only has an age and nothing else. And if you want to make this more specific, we can declare a class person. And person now inherits from animal at this point. So class. Oh, let's give animal just another function method. So that's the function speak, because every animal can speak. It's something bark, I don't know. But we don't have anything inside this, so we don't know what the animal talks or speaks or whatever. And then we have our person, which also as well needs an init function to initialize. And we have our age again, and we have a name. So let's go name. Every person has a name, and then we have to declare them. Say, okay, age equals age, was assigned to age, and name is assigned to name. Okay, what we can do now because we inherit from animal, we can simply use this class from animal, or the getter and setter we can use as well, but we can also override classes from them. So we can now say, okay, we can speak. We now override the method speak, so which is shown here as well. Overrides, you cannot see, this is too small, but this overrides the method from animal, and we want to return hello. Then we have our name. So at this point we override self.name. Or I have to make this better. Okay, and then we have now our person, which says hello, my name is, and then our name. So if we then want to make an instance of this person, let's say p equals person, and which is I don't know, 20 years old, and it's called Tim. We can then use our speak function, where we can see that this person, where do we, oh, we want to print it out. We want to print out what he says. And we then have, hello, my time. Did I call him time? Oh my God, Tim. So, and this is what an animal cannot do at this point. So because we don't have the right function for this, so we override the function speak from animal at this point. Okay, so to make this more, we can also declare the getter and setter for the name, but we don't have to do this right now. So to become a little bit more specific, we have another class which inherits from person. So student inherits from person, which inherits from animal, which means that student does also inherit from animal. So we have to declare. So the more and more specific we get, we can have another properties. We can add more data attributes, like we saw, like name. So for our student, this will now be a matriculation number and a time studying, so how long the student is studying. And as always, we have to define init function. So you don't have to strictly define init function if you don't want to, but if you do not define an init function, you cannot set data to your class. But this can also happen that you don't have to make an init function if you don't need to set some data to your class as an initialization process. So we have name, we have our age, we have your matriculation number, so, and we have our time studying. Let's make it a little bit shorter. So name equals name, and self.age age, on self.matriculation number equals matriculation number, and self.time equals time. So this is our initialization function. And after that, we can define other functions inside student. So the new function, for example, would be we come into next semester. So in the next semester, our time is +1. So we have, if we start with semester 0 as first semester, the next semester we have 1 semester at this point. Next semester. And the only thing what happens there is that our time, self-point time, will be +1. Semester. But we can also override functions we already had before. So we can define new function speak again, which overrides from the other function speak. But we can also later see on with what happens if we call the different functions. So we can return hello again. And name of student and the matriculation number is as follows. This won't work. We have to switch to comma. Okay, so now we overrode the method from person, the speak method. But later on, we can see what happens if we delete this function. So at first, we can now make an instance of our student. So we have our person, and if we have s, our student, is a student who is called. I'm a little bit messed this up. Okay, not bad. So which is called, I don't know, Sebastian, and 22 years old. His matriculation number is, I don't know, 4, and he's in the second semester at this point. So we have this new 2 data attributes. Oh wait, one moment. I want to make this the right way so it's not confusing. So I think it's a little bit more clear then. And we can just try to print out what this one speaks, our students. So here we have at one point the person, which is a person, which is more general than our student, and a more specific student at this point. So we can run this out and have, what do we have? I know my name is. Okay, so at this point we have my name is Tim, which is only the speak out of the person. But as we overrode the function here, we have hello, my name is Sebastian, and let's make this. So, and the matriculation number is 2551234. So what happens if we don't have this function at this point? If we comment this out, then we use, if we want to speak up for the student, we use the person function because we don't have any function, but we inherit it from the person class. This means that now, if we run this again, we become the speak function from person. So this one where we have Sebastian as a student, but he inherits from person, but he can also use the speak function of the person. So now he called simply out his name because we don't have any other information here. And we can use function from person as well. Okay, do you have any questions about inheritance? Because this can be pretty complex if you do more and more about this, but this gives you a lot of structure and saves a lot of time, and if you want to. So I would say we can make has itself a short break if you want to, about 5 minutes. I think it would be enough. We're pretty fast today. So take a little bit of time to think about it, or if you want to get explained something else again, because it's not unimportant to know what inheritance means and after doing something. Look if I forgot something, but I don't think so. Let's have a look. Okay. Okay, I think there seems to be no questions. If you think you have questions again, so we now go on with Git. And if you think you may have questions, just ask if you want. Today we have enough time, so just feel free to ask. But now we want to introduce into Git, and this may be important for your project, which starts next week. And Git is a tool where you can manage your project if you work in groups. So for the project, you will work in groups of 2, and if you both want to work at the same code, this is pretty good for Git. So you can have your documentation, so your code is documented at this point and who changed what, and you have your project history where you can push your code to the server and you see what was pushed at this point and who changed which code snippets. So you can merge your changes after you work at your code. So there's parallel team working, so you can both work on your code at the same time. And your project is stored at the servers of GitHub, so on our GitHub servers. So it's accessible for every member of your team. For the project, you don't really have to use Git, but this is a suggestion from us. So to use Git because it's pretty easy for this point. There are other ways to manage your project as teams, but if you know how to work with Git, Git is pretty easy to use and it's much more effective. So what's good about Git is that every developer at your code had his own copy of this repository. So we will see later on how to clone and how to pull something or your code from repositories. So you have your own copy, which is local, and you have to push your repository, also new data, to make this global for the other ones. So with GitHub, you can use your distributed working at this point. To become much more information in detail, you can go on the site from Git itself, from the documentation side, which is much better in detail. Like I can explain it right now, but you will see. Firstly, I think most of you did already install Git, which is totally perfect. If not, you can do this as you want. And here, this is the site which looks like where you can have much more documentation and more explanation about all the different operations. Okay, let's have a look about the Git commands. I simply prepared something. I'm not sure how good you can read this. At this point, I think nearly not. So, okay, so if you want to, so this is a right now is a inside a file where you have your command line, and inside your command line you can hopefully use the git command. So which you can check if you use git minus version, and there you can see which version of the git you have. If this does not work, feel free to ask your tutors, which may know an answer of this issue. So you can set in Git your username and your email, which we do not right now because we did this. I did this already here. So you can make this global and say your name and your email. At this point, you have the push and the pull commands. So git push means what we can see later, that you push your changes to the server of Git. The pull command does pull the changes from the other one. If your team partner made some changes and pushed to the server, you need to pull the changes so you are ahead of the new code. This is what we do not now, but at first, no, that's not. You need to use the clone command. So with git clone, you clone your the repository, and I did this already here. So later on in the exercise sheet, you will have a task to do this as well, and you will become this one, which is exercise 5.3, and you have to clone this repository into your folder. So I'm not sure if this will be, yeah, this will be overwritten, but if we go one step ahead, on this, and this should look like this. I mean, this much bigger. Oh, so this should look like this one, so that you cloned everything of the repository, which is nearly empty. There's a text file where you have to make some stuff with. Okay, then you clone this one, and you can change inside this repository. So at first we have to go into it. Exercise 5. Too many arguments. Oh, sorry. So we go into it, and now you see you're in a repository which stands master. So master branch, so Git belongs to different branches. So you have master branch, but you can also make other branches, which is useful for you because you can work in a separate branch, and you can merge the branches after you know your code is running and it works well as intended. And then you can merge them into your master branch or in any other branch. So your master branch will always stay clean and with working code. Okay, what have we now? So we can use some more commands. If we have new files, for example, we need to add them to our staging area. This is called our staging area. So everything which is here is local at this point. So if you change something, so we can add a new file. Let's look it up. Where is it? So we have this is our repository inside our folder. And if you want to add a new file, we can do this in the command line, but also here. We have new file. And we do now have inside on our repository inserted a new file at this point. So this is just an example. Later on, you have your Python code, not just simple TXT files, but it's only for as an example. So in this file, we can write down new file, and can save it. Okay, so if we now want to add this file to our staging area, we need to use git add. But firstly, we are on the master branch, which is not pretty common. So we just want to go on another branch. So this is done with the checkout command. So we can say git checkout, and with the -b at this point we just simply jump directly to this branch. So you can create a branch and name it, but with the -b option you can directly switch to it. So if you use -b and say example branch, directly jump to example branch, and we do now see where we are. So at this point here, in brackets, we have example branch, which means that we jumped from our master into the example branch. And we now have a copy of our code, and every change we are doing at this example branch will not change the master branch. This will is only done if we use the merge command, so like here, git merge branch 1 and branch 2, or just simply merge branch 1, where we merge branches together. So this means that if your code on your master branch, nothing will happen at this point. So if we just change our file at this, so we had, let's have a look, we jumped on our new branch. We have the new file. Let's go ahead, go back, and with some there are some other commands which are like diff or status, where we can look up what we changed. So if we use git status, we now know that we have a new file. So it's underlined in red in this terminal, which is not stored into the staging area. So if we now want to push something to the master branch, nothing will happen because we did not store this to the staging area. So if we use git add new file.txt, we do now add this one. And if you then check again from this to the status with git status, it's now green. We have a new file, which is called new file.txt. And right now we stored this new file to the staging area. And what we have to do now is to commit. So we work with commits at this point. And if this is committed at your branch, you can push this one to the server. So you don't have to simply add some files and everything's done. Now you have to commit. And with git diff, you can see what you changed. So, oh no, I think we have to untrack this one. Then we could see this. So now, if we now change the file, say new file with changes, and have this, and we now use git diff. With this command, we can clearly see what we changed from the other one. So new file was the first one, what we have in our file at first. This one underlined in red, and with changes, so this is what we wrote at this point, are the new things. So you can simply see what's new at this point with the git diff command. With git reset, which we can see after this, if we make a commit, you can reset some commits if you accidentally committed some changes and you don't want everything to be pushed. You can reset your commits, so you can then work again with your file and make a new commit out of it. But we can now say git commit because we have our new file. We now want to commit it, and if we commit this one, we can use the option -a for save all changes inside the staging area, or we can just say git commit new file if you only want to commit this one new file. And with -m, we can make a commit message, which is pretty useful if you want your history and want to know what did you change while you commit. So let's say if you write in your project, you made some new stuff, or you made some bug fixes, you can just simply say bug fixes, and everyone knows fixes, and everyone knows what you did in your commit with one look around it. But we didn't do any bug fixes. We made an example. Let's call this example. So now we inserted our new file into this commit. So we are now ready to push this one to our server. So this is the last step. You have to commit your changes. Now, at first you have to add your changes to the staging area, and you commit your staging area at this point. And after you committed your changes, you can push them through the server, so that the other one who's working at your project can update his own Git branch and use your changes at this point. So if you use Git pull, he becomes the new version of his code. But before we push our code at this point, we can use Git reset if we made something wrong, and you can use head. Oh, this is called tilde in German. I'm not sure how this is called in English, but I hope you see this. This means head -1. So at this point we are at our head, and if we reset this one, this is our last commit. If you want to say this in this way, and then we reset our commit and have our old version. So if we check for the status, we now have again the new file in red as we had before. So we reset it completely. What we saved before, committed before. And again, now we have to add our changes to use git add. So at this point we have now again the screen again. So this is now again in our staging area, and we have now to use commit again, -a, -m, new example, because we didn't change anything, but you could, if you want to, change anything. And we committed this again. And if you now want to push this to our servers, we just use git push. We have to, this is important. You firstly have to set your upstream. So this means your branch you created locally is not globally in the server at the beginning. So you have to push your branch to the server. That the new branch, the example branch, is on the server, because everything you do here, right here, is locally at first. So we'll just say push -set upstream. So this is pretty cool that Git has told you what to do, and you can say origin. And our origin is our master branch at this point. Oh, what have I done wrong? Oh, so I think I don't need this. Origin master. So we then have to push to our master. Oh wait, one moment. What have I done wrong? Oh, I forgot about this. I'm sorry. Git push -set upstream. Origin, and then the name of our example branch. So, and at this point, you can see that we pushed our changes, which is done here. So there we made our upload from our new code, from our text version. And here we created the new branch globally, the example branch. So now, if we look it up globally on GitHub, we have the example branch. So right before we didn't push it, there wasn't any example branch globally, but now we have them because we pushed it. We have to set the upstream origin example branch, and we can now your team partner can now pull from this branch. So he has to be on the same branch if he wants to pull something. Well, I cannot pull something right now because I have no team partner. So if I want to pull something, everything's up to date. So if you see this, everything is up to date. There is no change at all at this point. All right. What also happens pretty often is that you become merge conflicts. So in Git, if both of you work at the same file, Git tries to, if it's merging, Git tries to merge your code. But if you both change something at the same place, you become a merge conflict. And this looks as follows: that you have these arrows here and these equal signs here, and at the top over them, so above these equal signs, you have your changes, and below them you have the changes from your team partner, and you then have to decide by your own what stays this way. So JIT has then this how it's called, this error, and you have to fix this on your own. But at the other hand side, if you're not working at the same file, but not in the same lines, for example, JIT will merge for you at this point. And after this happened, so I cannot show you this at this point because no one changed right now something at the file. At this point, you come in a new stage where you have to make your changes, and you then have to write JIT merge to merge your changes into your branch. So JIT merge, and yeah, this is it so far. Okay, so today we were pretty fast, I think, but this was the last great topic, classes and introduction into JIT. If you have any questions about JIT, JIT can be pretty complex at first. At the beginning, JIT was complex if you don't really know what you do, and you can mess up your code and mess up your project if you're not knowing what you do. So if you have any questions, feel free to ask. We have half an hour at this point, and this can be important. But again, if you don't want to use JIT, you don't have to. So if you have other versions or how you want, you can submit your project at the end to the Moodle page. So either with JIT into JIT, so push your branch into JIT, so we can see it on there, or to submit this the project at the Moodle page, so you can decide if you want to use JIT or not. So it's just a suggestion for us because it can be much more efficient if you work this way, but you don't have to do this. For the project, which begins next week, you can simply write an email to one of the tutor of your choice. If you have a partner, if you want to have a partner. So these are groups of two where we work in a project. And yeah, if you know your partner 2 and 2, you can write simply mail. We will write this down on the Moodle platform as well, with which one you want to do the project. But if you don't have any preferences, we will assign randomly. So you will become just one partner for the project. And also next week, we will split the lecture. And on the one hand side, the EduTechler will become another lecture because next week is about the introduction into the project. So this means the EduTechler are preparing another project. Another project is the other students. So the EduTechler will become, there will be another lecture, but we will also load this up to the Moodle platform so that you know where you have to go next week. Okay. Do you have any questions so far? We have half an hour left, but we can also, so we are at the end of the lecture today. We were pretty fast. If you don't have any questions, we can close at this point, but keep in mind that this can be rather complex. So feel free to ask right now. Yeah, if you don't have any questions, you can leave lecture if you want to, but otherwise we can have a break about 5 minutes so that you can ask your questions right now. And I have to drink something. Oh, we didn't call it next semester function method, didn't we? Oh, we can do this if we want. I'm not sure if this is important, but yeah, come on, you will now then see what happens if we do this. And I'm in the enrich in time self.time semester. Okay, this is just to showcase what happens if you go to the next semester. At the first point, we have to speak up, and we're in the second semester. And we're in the second semester, but if we call our new method as next semester, then we should be in the third semester. So here you can see that we just changed the data inside our student with this one method, and we're now in the third semester, not in the second. So because we called this method and changed data inside our class at this point. Okay, but if you don't have any other question, I will upload this as well as a lecture where you can look everything up again. But if you don't have any question left, if there raises some questions, feel free to ask the tutors. I think they will also have an answer about this. But otherwise, have a nice week and goodbye.